Okay, lesson 1-7 triangles, day 1. So I think most of you are already aware of this, but the sum of the angles of a triangle is always 180 degrees. So the equation, whenever we see a triangle, 3 angles, measure of angle A plus the measure of angle B. Sorry, guys. Plus the measure of angle C is equal to 180 degrees. Oh, all right, so solve each of these, okay? In triangle ABC, I know 2 angle measures. I'm looking for the third. That's the measure of angle C. Add them all together, add it to 180 degrees. Combining like terms, 154 degrees plus the measure of angle C. All right, and now when I subtract 154 from both sides, the measure of angle C would be 26 degrees. So just a very simple use of the triangle sum theorem. Okay, now little algebra. All 3 of my angles are in terms of x. 3x plus 9, that's angle 1, plus 3x plus 4, that's angle 2, plus 8x minus 1. Still a triangle. Sum never changes, 180 degrees. Okay, let's remember here, let's first combine all the like terms. So all the x's, 3 plus 3 is 6, plus another 8 gives me 14 x's total. And then my constants, 9 plus 4 is 13, 13 minus 1 gives me positive 12. Okay, so we're just combining like terms before we even start to solve. Okay, subtracting 12 from both sides, I get 168 degrees. And then when I divide by 14 on both sides, I get x is equal to 12. I'm not finished, but for homework, I want you to actually find the measure of each angle in the triangle. Okay, and then lastly, the angles of a triangle are in the extended ratio of 1 to 2 to 6. So remember ratios. When we get these just represent coefficients to an x. And then I set it equal to whatever the situation is in the problem. So if I'm talking about the angles in a triangle, I know the 3 angles add up to 180 degrees. Combining like terms, 1 plus 2 is 3, plus another 6 gives me 9 x's. When I divide both sides by 9, I get x is equal to 20. So now to actually answer the question, we have to plug back in, right? Find the measure of each angle. So the smallest angle would be 20 degrees. The next angle, 2 times 20, would be 40 degrees. And then the largest angle would be 120 degrees. And as a quick check, when you add those 3 values together, it still adds up to 180. Let me fix these things up for you. Okay. All right, exterior angles. We've talked about a region being exterior, and we always associate exterior with outside. Okay, so in each of these situations, the angle numbered angle 3, that's the exterior angle, okay, all on the outside. These angles, these are called non-remote interior angles. I want you to write that down because you could see it as we practice for the park. Well, what does that mean, non-remote? So let's say they're the interior angles. So they're inside the triangle, and they're not adjacent. Okay, so they're not adjacent to this exterior angle that we've already determined was angle 3 here. So again, this is a phrase that you might see on testing, so something that please have in your notes. Okay. The exterior angle sum. The measure of angle 1 plus the measure of angle 2. Okay, and I'm going to come back to this. What are these? These are interior angles, and they are not adjacent to angle 3, because that's the exterior angle in the figure. So the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle 3. Okay, so now if I have two interior angles of the triangle, I can find what the exterior angle measure is, as long as I'm not looking for an exterior angle that's adjacent. So meaning if I labeled this as number 4, I can't say angle 1 plus angle 2 is equal to angle 4. They can't be adjacent to the exterior angle. All right, so using that sum, measure of angle 1, that's my exterior angle. That's going to equal the sum of 80 plus 18. So my exterior angle would have a measure of 98 degrees. All right, now we can use the property and solve for an interior angle measure. So 124 degrees is my exterior angle. That's equal to the sum of the two interior angles that are not adjacent to the 124 degrees. Subtracting 59 from both sides, I get the measure of angle 2 is equal to 65 degrees. Okay. All right, triangle inequality. The sum of any two sides of a triangle must be greater than the third side. Okay. Triangle inequality. So it makes sense that these aren't equal signs we're using. So what does this say? It says the sum of sides A plus B has to be greater than side C. What's another one I could write? The sum of A and C has to be greater than the length of side B. And then lastly, the sum of sides B and C has to be greater than the side length A. So the sum of any two sides has to be greater than the third. All right, so state whether the given lengths can form a triangle. Okay, so 3 sides, 3 inequalities. This is our check. Is 5 plus 9 greater than 4? 5 plus 9 is 14, so that's good. Is 5 plus 4 greater than 9? Well, 5 plus 4 is 9, so this inequality fails. As soon as an inequality fails, can these form a triangle? No. No triangle can be formed. Okay, you don't even need to check the third inequality on that example because it fails one of them. Okay, next, 9, 2, and 12. So 9 plus 2, is that bigger than 12? 9 plus 2 is 11. Okay, that works. 9 plus 12, is that bigger than 2? Definitely. Okay, 21 is bigger than 2. That one works. And now lastly, is 12 plus 2 bigger than 9? So 12 plus 2 is 14, and that's bigger than 9. So can 9, 2, and 12 be the sides of a triangle? The answer to this is yes. Okay, and then lastly, side lengths of 3, 3, and 3. So I only need one inequality here because all the side lengths are the same. So is the sum of those two side lengths going to be bigger than the third? No matter which one I set up, then yes. So, and I'm just going to give a little preview. When all the sides are equal, that's known as an equilateral triangle. We'll talk about those more in class. All right. And then the last slide, I think, yeah. The relationships of sides and angles in a triangle. And we'll do examples of these after we get to discuss this a little more at length. In any given triangle, the smallest angle is always opposite the shortest side. Similarly, the largest angle will always be opposite the longest side, and vice versa. Okay, so the longest side will always be opposite the largest angle, and the shortest side will always be opposite the smallest angle. So what do I need you to take away from this? In triangles only, angles and sides correspond with each other when they're opposite. So angle B corresponds to side B. Angle A corresponds to side A. Angle C corresponds to side C. And vice versa. So I'm actually going to make those arrows double arrows at the ends. Okay? We'll do more examples of this. Just please have the notes completed. Finish that one homework problem, and that's it. Thank you.